Hello, this is David Hall, and it is my pleasure to welcome you all to Day 3 of a series of IoT conference tracks within the IoT Days online event, presented by the IoT M2M Council. The topic for Track 1 today is Edge Compute in IIoT, and is sponsored by Nimbalink. You can see the full schedule in the Resources section of your interface. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets that you can use. All of these widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. If your slides are delayed, pushing F5 on your keyboard will refresh the page. You can find additional answers to some common technical issues located in the Help widget at the bottom of your screen. An on-demand version of the webcast will be available later today and can be accessed using the same audience link that was sent to you earlier. Now it's my pleasure to introduce Keith Kreischer, the Executive Director for the IMC. Keith, good morning.
Good morning, Dave. Thanks. And thanks for being here, everyone, our speakers and our audience. Hoping that everyone attending this morning is keeping safe and well in these difficult times. Welcome to this online conference track, Edge Compute in IIoT, brought to you by the IoT M2M Council, as well as Nimbalink, Telus IoT platforms, Locent, and Digi International. My name is Keith Kreischer. I'm the Executive Director of the IMC. We've got a great panel for this morning, and I'll start introducing our speakers in just a moment. But first, I'd like to take 2 minutes to introduce the IMC for those on the call that may not know us. The IMC started in 2014 with a fairly eclectic group of IoT solutions providers, a mix of big telcos, MVNOs, providers of hardware and software that got together to form a trade association for the IoT sector. The group consensus was that we did not want to be a technical standards body, nor a testbed organization. There are plenty of good people working on those issues, and they are important. But we see those groups as essentially vendors talking amongst themselves, and we wanted to learn more about people that buy IoT stuff. And by that I mean enterprise users, product makers and designers, apps developers that buy connectivity, hardware, and software to connect devices in the field. What did these people look like? What did they need? And how could we help them? We started putting out content, pretty much anything we could get our hands on, white papers, use cases, blog entries, newsletters. And we didn't ask people that wanted access to the content to pay us anything, but we did ask them to self-identify as buyers, not sellers, to join our organization as adopter members and give us permission to talk to them, and crucially, to give us fairly extensive tabulatable demographic information. That whole effort turned out to be much more successful than we could have hoped. The IMC now has 25,000 rank-and-file adopter members from around the world. We cover 24 different vertical markets, everything from automotive manufacturing to building and construction to retail point of sale. We get 200 new members weekly, and they come to us inbound. We don't recruit. We do curate our member roles to keep them around 25,000, and we look at our adopter membership as the largest market segmentation study ever conducted for the IoT sector. The IMC board now includes some of the largest companies in the industry, AWS, HPE, Tata, Vodafone, but also smaller influential solutions providers. Many have joined us today. We see ourselves at the IMC as an IoT accelerator. Our mission is bringing together buyers and sellers to expand the adoption of IoT technology for the common good. And we look at today's webinar on Edge Compute in IIoT as exactly in keeping with that mission. Again, I'll introduce the speakers in just a minute, but we do encourage you, I'd like to say, to submit questions during the presentations. In some cases, we will address those questions immediately after the presentations. In some cases, there may not be time, but never fear. If we don't get to your question, our presenters will have those associated with your registration, and they will address them after the live session. So please ask questions and feel free to do so. And with that, I will introduce our first set of speakers in this case. Brandon Hart, who is Director of Technical Business Development at Nimbalink. Brandon's got more than a decade of experience in the wireless industry, has worked extensively with developers and engineers to aid in deployment of M2M and IoT solutions. By combining his business experience with technical knowledge, Brandon's able to effectively bridge the gap between sales and engineering. An active maker, he is passionate about connected devices and regularly speaks on a variety of topics in the space. Good morning, Brandon.
Good morning. Thank you for having me.
Thanks for being here. Also speaking with Brandon is Dave Smith, VP of IoT Solutions at Get Wireless. Dave's got responsibility for technical advisement and thought leadership around products, solutions, and services, both inside and outside the Get Wireless portfolio. He's a tenured technology professional, skilled in LPWAN, IoT, wireless, telecommunications, software development, testing, and embedded systems. Dave began his career at NASA's Jet Propulsion Lab, and prior to joining Get Wireless, served as CTO and CDO for two innovative IoT software and hardware manufacturers in the Twin Cities area. Good morning, Dave.
Good morning. How are you doing?
Great. Great to have you. So with that, Brandon, Dave, take us away.
Okay. Thank you very much. Yeah, so we want to talk about ensuring successful development of edge devices. And I'll just start off by saying that this is an incredibly broad topic. There are lots of ways to ensure successful deployment of edge devices. So there's no way that in our allotted time here we can get super in-depth. But what we can do is we can point you to kind of what we're building upon here for our presentation today, which is a 10-week webinar series that Dave and I did together called Successfully Pushing Intelligence to the Edge. So if any of the topics that we're going to very lightly touch on here today is interesting to you, there's a lot more information, 10 weeks worth of information at that webinar series as well. So that's something you can find after we get done going through the presentation. But I thought maybe it would make the most sense to just kind of address who we are, what our perspective on all of this is, and why we're even talking about this in the first place. So first off, who is Nimbalink? So Nimbalink is the company that I work for. We are a rapid IoT solutions company, and I know that's a generic statement, but in our case, that's really what we focus on, is making the development of IoT solutions as quick and as easy as possible. Our tagline is smart, simple, cellular, and that's kind of how we do this. We focus on the cellular component of most of these IoT solutions because that tends to be the part that is the most difficult and tends to lead to the most difficulties and the least success in deploying edge devices. So that is our focus when we talk about trying to develop cellular IoT devices and IIoT devices. Of course, we've developed a whole lot of solutions, and we have to be crazy developer friendly. By the way, the first time I wrote that, I actually meant that we were crazy about being developer friendly, and then I realized you could also interpret that a different way. So I would also say that we are indeed friendly to crazy developers. So whichever way you like to read that, it is still applicable. And if you like kind of how we present things and how we talk about things, and you want to learn a little bit more, we do, of course, also have a full series of educational videos called From the Workshop, and we would encourage you to check those out as well. With that, I'm going to turn it over to Dave to let him introduce Get Wireless.
Hey, thanks, Brandon. Yes, so my background has always been product development from a manufacturing standpoint. And as an IoT product developer, one of the things I saw in the industry was a lack of really good support from a distribution standpoint. Tended to be holding the markets back, right? Can't get to that scale until you have scale of supply. So I moved over into the distribution side. And Get Wireless is a leading value-added distributor of cellular and LPWAN solutions that connect the Internet of Things. And my job here is to create solutions based upon products and pieces, parts that others make, put them together into effective, deployable, scalable, useful solutions, and push those out to the channels. Our customers are not generally end users. we sell to mobile network operators, OEMs, VARs, integrators, solution providers, and the like. But even though we don't sell to end users, we do provide a lot of services, pre, during, post, technical sales, support, all that kind of stuff. We're a stocking distributor, so we have lots of product on hand. And when I say stocking, we have lots of product. We usually ship stuff really fast. So we work with our partners to enable them to deliver solutions quickly and those that work well. So that's all I'm going to say about Get Wireless, because I don't like talking about myself so much. Let's move over into this graphic. You're going to see this graphic several times in our talk today. It was a big part of our webinar series that Brandon mentioned. We use it in different ways. You're going to see different versions of it. But really what it boils down to is, depending on who you are, your edge, your cloud may be in different places, right? So one of the things you need to understand is, where is your edge? Are you making little sensors like on the left there that, very simple, very tiny, and they require assistance to get information to the cloud? Are you talking about a more sophisticated sort of device that is perhaps more powerful in terms of computing and has connectivity built in and things like that? Some people consider the edge to be gateways. Companies like Cisco, right? They consider the edge to be a gateway or a router. And so depending on where you are and what you're doing, you need to understand where your edge is, because the capabilities of that column of or class of device is going to determine to a large extent what you can and can't do today. Then, of course, you have the cloud on the right-hand side, and you have to do the same thing on your cloud. What do you actually consider your cloud? Is it just your application, or is it AWS as well, right? So understanding where you're positioning and where you're starting from is very, very important. Like I said, you'll see this diagram several times hence. Another thing to do is to understand what stage of development you're in. Obviously, we have a wide audience here. Some of you may be just thinking about a project. Some of you may be in the middle of planning it or developing it, or some of you may be owning and operating existing IoT solutions and maybe want to learn how to improve how you did that. So we're going to address these different stages to give you some suggestions, some techniques of how you can move forward in a less risky, more success-oriented way. There's an overall process. Most people who implement IoT systems, I've done a lot of them, I found that they tend to fall into a category of the ones that worked well and were successful and the ones that were not. And there's pretty sharp demarcation, obviously. But one of the key things that you're going to find that companies forget right off the bat is a thing called an IoT Readiness Assessment. I don't know how many of you have worked for a company that has said, we need to do an IoT system because we know we can save all this money or increase these efficiencies or gain these benefits, whatever they are. And they run pell-mell, and the engineers are all hot for it because they know how to do it and they can get it done. And they go to deploy the system and they find different parts of the company simply cannot work with the system. I'll give you an example. I worked at a company one time who wanted an IoT system, and this was a manufacturer. And so when they sold product, they would get a PO, they would invoice, they would get paid. That's how their finance was set up. I know this because I reported to the CFO. We created a system where they were paid periodically from a per-month basis. And we actually had the system all done, ready to go, but we couldn't deploy it because finance was not set up to receive recurring payments that were not associated with the PO, for example. So this IoT Readiness Assessment is something that you're going to need to look at. I'll go in a little more detail on the next slide or two. You need a business model. Business model is your touchstone. It should quantify everything you need to be successful. And then you start doing kind of the waterfall thing. You architect and implement your solution. You have to deploy it, operate and manage it. All of these phases have unique challenges, and they have unique opportunities to achieve success. So each one of these stages is really important. In a different webinar series that we did before that Brandon mentioned, we have a whole hour talking about this and going through that. So if you'd like more information about that, I'd refer you to that video. But the IoT Readiness Assessment, what you're going to do is you're going to look at the company and look across the company. Look at your processes, right? Your systems, both IT and operational technology systems, right? How's your organizational structure? For example, if you're going to actually be deploying something and you're a manufacturer, most manufacturers don't have field technicians that are used to going out and deploying solutions, for example. That would be an organizational structure issue. And you also need key stakeholder buy-in. The last thing you want is to get to a point where you need a decision made and the person who needs to make the decision is not fully on board with the system, because that will be a roadblock. But if you do this and you look at yourself in the mirror as a company and understand changes and are willing to make the
Dave, we're losing you.
Systems fail because they didn't do an IoT readiness assessment. So the next thing I'd like to mention is a business model. The business model is where you're going to collect everything about your system to know why you're doing it, right? It's going to show you what the benefits are and the costs are, the time frames, right? It should also dictate a life cycle. One of the failures of many business plans is that they assume that once they deploy a system, it's going to stay that way forever. And those of you who have deployed cellular systems, for example, and gone through a 2G sunset and a 3G sunset, know that this is not the case. So a good business plan will include the life cycle of the system. But really what you're doing with an IoT system business plan is showing how you're translating data into value. And that has to be very, very clear. The good thing is, if you are clear about that, when you get to the point where you've deployed and you're hopefully operating the system, you can know that, one, you're done. That's one of the big benefits of a business plan, is it does let you know when you finish what you intended to do. But it also lets you measure how successful you were, right? Did you meet the goals? Did you meet the time frames? Are the operational costs within the realm that you wanted, right? You can see how successful you are. That's not just to point fingers at the end and things like that. It's actually to allow you to hone and improve your ability to create and deploy IoT systems over time, so you can get better and better at them. Another thing with the business model is this is an IoT system. So one of the fundamental characteristics of it is that it is deployed in one state, and over time, it adds features, capabilities, capacities as it exists the longer it's deployed. So the business model needs to understand that the initial deployment is going to have one set of performance characteristics and capabilities, and at the end of the life cycle, it will have another set of performance and capabilities. So that is something that should all be quantified in this business model. Doesn't have to be really complicated. Doesn't have to be really long. It doesn't have to be a 100-page document at all. I've seen 2, 3, 4-page business models that capture everything that needs to be captured. So it's not a complicated thing, but it is and should be your touchstone throughout the whole rest of the development and deployment of your system. And now I'll hand it over to Brandon.
Yes. So as we were talking through there, Dave was kind of running through the ideation stage of putting together an IoT solution. And I know, as somebody who likes to jump in and start slapping stuff together, that sometimes it can be difficult to walk through all of that information and really take the time to sit down and think it all through, make sure that your company is ready to take on this IoT solution you want to develop. But it is critically important to ensure that you're not going to have some unknown, unforeseen circumstances that is going to prevent you from being able to move forward. similarly, as we move into the next stage, which is, we've already now thought through exactly whether we should do something, and we've thought of what that thing should be, whether it's a good fit for our company and how to move forward. Now we need to talk about how to actually put the plan in place to ensure that doing what we've now decided to do and decided that we are ready to do will be successful once we actually start deployment. So first off, we need to plan out this entire solution. And you can see that same graphic we looked at earlier, but this time it's all jumbled up. And that is for a reason. This is often how things are going to look as you start to get into the planning stages. You know that you've got a lot of pieces here. There are a lot of different things that somehow need to all coalesce into an easy-to-use and reliable solution. So first, we talked about earlier, there's the edge, there's the network, there's the cloud. Those things need to be defined. You need to be able to line those up into the appropriate categories, figure out where your edge really is. Is it between the little sensor node in the field and a gateway? Is the gateway part of your edge? Is it so therefore between the gateway and the network? Where does your edge exist? Where is your cloud? And once you define all of that, it's really going to drive a lot of the rest of your planning. For example, it's going to determine exactly what types of software you can put in place, not just in the cloud, not just what type of platform, but also the specific types of software that you can run locally on your device. Gateways have a lot more power and a lot more compute in them than a little sensor node that's running off of a coin cell battery is going to have. So a lot of this is going to help you determine if you've got the ability to deploy, AI on your devices or AI in the cloud, machine learning algorithms on your little sensor nodes that are in the field. Can you do something in a gateway that aggregates the information and analyzes that information, the edge computing of all of this, to make sure that only relevant information is actually being transmitted and so on. The protocols are often determined by the cloud side more than they are the device side, but the protocols that you use can have a huge impact on the overall success of your solution. Is all of the data absolutely critical to reach the other end? If so, you might pay a price in terms of larger packet size, larger number of packets, more back and forth communications. But by doing all of that, you ensure that every little bit of data reaches your cloud. Alternatively, if you've got a low power system and what is the most critical there is simply having your device be able to last 10, 15 years on a battery, then maybe you're okay with sort of waking up, sending data, going back to sleep again without any kind of acknowledgement, without any handshaking and assurances that the data has actually made it where it's supposed to go. And if your solution can tolerate that, then that'll make a big difference in terms of how you actually deploy a lot of this, what protocols you use. The protocols also have a big impact on your costs to operate these systems. If you're using cellular, then remember that the networks that you're using, the cellular networks, really base all of the charges that you are assessed on how much data is being sent through it, both up and down. And that's not just your payload either. That is all data. So once the connection has been established and you start sending data through that connection, all of your overhead, all the headers, all the three-way handshakes, all of that is billable data. So all of this is really going to be critical to understand as you get into setting up your solution. Again, those protocols, if you can keep the overhead down, if you can keep your header sizes down on each one of your packets, if you can maximize the payload capability of every packet you send, you're going to pay less overall for your cellular service. On the same side, you're also going to save in power. And so power considerations are very big and very important to understand at this stage. Again, this idea of AI and machine learning may seem kind of like a distant future idea, but I assure you it isn't. AI and machine learning is being adopted very, very quickly, is improving very, very quickly these days, and even can run on very low power devices. So some of your edge devices, it may make a lot more sense to do some machine learning on those locally on those edge devices and be able to determine whether it makes sense to send certain types of data, be able to look at data and figure out if there's going to be any reason to notify or alarm. If not, maybe just don't send the data. So those are types of things that you can take into account. But all of this, again, needs to be planned ahead of time. So in the planning stage, you're taking this messy diagram over here and figuring out which pieces you want, lining them up, making sure everything is in line and orderly so you know how to go from your edge to your network to your cloud.
Hey, Brandon, we got a question from Amadou. He says, in case MQTT protocol is to be used, how could we identify the edge in the end-to-end architecture?
Yeah, so MQTT is interesting because there's a broker that sits in the cloud, but typically it is in the cloud. So even using MQTT, you're really talking about a device, and again, that could be a sensor that talks to a gateway, and maybe your gateway is what actually is connected via MQTT, or it could be the individual sensor itself that is utilizing MQTT to talk over the network into the cloud. So in either case, that's really where it comes down to, is where would you say is the edge of, I hate to say this, but the edge of the edge, meaning, where is all your data being collected and aggregated before it is then being sent up to the cloud? And wherever that happens to be, again, whether it's your device, whether it's a gateway of some sort, whether it's a local computer that then sends everything over Ethernet, whatever the case may be, that would be where you would define your edge, and that would also then determine how you architect your solution to ensure that it's going to be able to successfully pull all of the data that it needs, only use the amount of power that is necessary, and only send data when it's absolutely critical to do so.
Yeah, I think many of these things come down to cost too, right? If you have a more expensive, call it edge device, like a sensor, and it has greater capability, can do TCP/IP and stuff like that, then you could put MQTT down right there. Or as you mentioned, right, you could put it at a gateway and have a much less expensive, much simpler sensor that just talks to the gateway, and the gateway forwards it using MQTT. So I agree that it really depends on how you're going to configure your system. You could actually do it pretty much anywhere, right? Oh, we have a good one here. I'll let you start to answer it. I cannot pronounce the first name, so apologies, please. But the person with the last name Singh says, "How is AI ML in the edge to be done?"
Yeah. So I don't know that we have enough time here today to really dive into that. But what I will say is that typically AI is most often found in the cloud side of things. There's a little bit more horsepower required there, whereas machine learning and machine learning algorithms can exist on your local device, on your edge device. They don't require typically nearly as much of the compute power. But Dave actually spoke quite a bit about this in our webinar series. It might be worth going back and checking that video out. Again, I would love to keep talking more about AI and machine learning, but we've got about 10 minutes left here, and I don't know that we have enough time to really do it justice.
Yeah, no worries. I would just say look up TinyML. That allows you to do machine learning inference in very highly constrained environments. That'll be the thread that pulls the sweater apart. So search for TinyML, and that'll get you a lot of your questions answered.
Perfect. Yep.
All right, I'll let you go now. Now you can move on.
Well, I mean, speaking of AI and ML, I mean, when you get into, so now we've talked about the ideation stage. So, should you do anything, first of all, and what should you do? And all of that is kind of covered with the business model and, everything that Dave talked about early on. And then that feeds into the planning stage, which we just kind of covered, where we talk about actually figuring out how to line it up, how to do it. And then we get into the development stage of actually making it happen. So this is where you get to open up your PCB design software and get your development kits and get going on actually putting something together. And in the development stage, we talked about AI and machine learning, but basically the best way you get started with AI and machine learning is, Dave mentioned there are some specific packages and specific types of AI and machine learning that you can take a look at. Really a lot of this is going to come down to get a dev kit and get started with the dev kit and try to figure out exactly how these things fit together and how they work. That is definitely I don't think there's any situation where it's more true than with the radio architecture and figuring out exactly how your radios are going to work with each other. This is unfortunately something that is often held off till later on in the development process because people like to focus on, I'm making a tank monitoring solution and my tank monitoring solution is going to be the absolute best tank monitoring solution ever. And so you tend to focus on making that tank monitoring solution work extremely well and then leave the communications part till further down the road after you've got your tank monitoring solution working really, really well. Then you go to add a radio to it so that it can talk to the cloud and communicate out. And unfortunately, that will very rarely result in success. I won't say never.
It's too late at that point.
Yeah, it's too late. The radio is an integral and fundamental part of your IoT solution. So if you're going to include a radio, especially a cellular one, please make sure that you are getting a radio dev kit. Again, could be a cellular radio dev kit or whatever, but make sure you have that and you're using it as a part of the early stages of kicking tires and figuring out exactly what's going to work for you. Eventually, once you have a completed design, you are going to move on to doing things like certifying your device. So please know from the very beginning of your development cycle exactly what certifications are going to be necessary and understand the requirements for those certifications. Again, if we're talking about cellular, a lot of those are very, very well laid out. There may be quite a bit of them. There may be a lot of them, but at least they're pretty well laid out and relatively well understood. You can obtain documentation that walks you through a lot of that, and you can understand the scope of what you're going to be in for once you have your final device designed and is ready to go. But even outside of cellular, there are a lot of other types of certifications that you may be wanting to do as well. So just, again, make sure that you know what the requirements are for those and proceed by making sure that everything you're doing at each stage of your development cycle is going to allow you to pass those tests and pass those certifications. Along with that is the power budget. So, we spend a lot of time in IoT and even just, even consumer devices a lot of times in consumer IoT, where we really kind of talk about battery power devices and low power radio standards and, how can I make the smallest, most power efficient device possible? So knowing what your power budget is, or if you need to bother with one at all, maybe you've got something that's plugged into a wall and has all the power it's ever going to need. But in most cases, that's not the case. Most cases, we're talking about little sensor nodes that are sitting out there on the internet in some way with a cellular connection or a short-range radio connection into a gateway of some sort. And you want that device to be able to exist on a charge, continue to work on a charge for a battery for 10 years, 15 years, whatever the case may be. So managing the power and knowing what your budget is for power is critically important. So if you know that ahead of time, and all of the decisions you're making when it comes to picking components and picking radio standards and determining how often your device will wake up and what parts of it will wake up, are all pretty critical to making sure that you've got a device that will fit within the power budget that your device needs to have. And from there, I'm going to let Dave take the rest of the development and then see us through the next slide.
Sure. You left me with the easy ones. That's good. Thank you. So the cloud architecture, there are a number of different cloud operators out there. Obviously, you've heard of the big three, Microsoft, Google, and Amazon, and they all offer some pretty comprehensive capabilities running the gamut from, as we said, AI/ML all the way on down to connectivity services and things like that. There are other cloud providers too, though, that focus on specific vertical markets or vertical capabilities or niche markets, and those are often worth taking a look at. ARM's Pelion system, for example, is quite a nice platform. It allows you to both develop and deploy, manage, and maintain large pools of devices very easily. And so it kind of integrates your operational technology folks with your development folks from the beginning. So that's one example of a kind of more vertically oriented cloud architecture. You need to understand, however, what your application is going to be first. Once you know the application, it's a fairly straightforward job to shop the major cloud providers and find out what they have that supports what you're trying to do. The good thing about that is when you do that, you're going to see opportunities for feature enhancements, capability enhancements, and things like that. That may send you back to the drawing board again to redo your application. But at the end of the day, understanding your application and its capabilities and then mapping that into a cloud architecture is the way to go. Edge device software, I mentioned ARM's Pelion platform. What they do is they support these small little tiny devices at the edge, make it really easy to write software, firmware as we would call it, for them. Doing that properly in a way that both matches your business model needs as well as maximizes the capabilities of the device is a bit of an art. It's not as easy as it sounds. So, for example, this power budget that Brandon mentioned earlier, that has a lot to do with the edge device software and how you run it, right? AI/ML, you can run machine learning inference right on the bleeding edge with less than a milliwatt of power cost, if you're going to do it from a power budget perspective, very easily. But then what you need to do is understand that to get to the point of doing inference, you have to be doing training, for those of you who are familiar with machine learning, and you do that training in the cloud. So you're going to have to be able to support that as part of your solution. One example of that sort of thing is one that touches that very center column on the networks. There's a company called AtomBeam. And what they do is they use AI/ML techniques in the cloud to enable machine learning inference at an edge device so that they can reduce the amount of data traffic over their communication channel, whatever it is, cellular, Ethernet, any other LPWAN technology, by 80–90%. That's a lot, right? And so if you have a data-intensive application and you're trying to use cellular, finding that your cellular costs are going to be too high because of the amount of data, there are opportunities to greatly reduce that and make that business model successful doing that. That's an example of also edge device software. Another big thing that you're going to have to do that's cellular is get a SIM or a service provider. That may sound simple. By all means, go give it a try. It's not necessarily as simple as it can be, even though the carriers will like to have you think that, but it requires thought, it requires preparation, it requires understanding and cooperation with the cellular providers. And so choosing the right provider that has the right coverage, right, the right capabilities, they are different. They offer a lot of similar services, a lot of similar capabilities, but they are different. So, for example, T-Mobile has a lot of 600 megahertz service across the country. If you're using an edge device that's going to be buried deep in a building, that 600 megahertz is going to propagate easily outside the building, much easier than like a 2.1 gigahertz signal from a different carrier. And so understanding the capabilities and the services that your different providers will give you is really important there. And I would encourage you, if you don't already know this, Brandon has, I think, more like 3 decades of experience, right, Brandon, on this? And you need someone like him to advise you. That would be my best advice. And then the last thing is, and Brandon, I should let you talk about this one because this is your specialty, the test labs.
Yeah. Well, thank you. I don't know about 3 decades. I think you're aging me a bit, but we will. So I know we're running tight on time, but what I will say is that engaging a test lab is a long process and something that I would not recommend people wait until the end after you've developed your device to do. All during the development process, once you've got a set of specifications for your device and you know exactly what it's going to incorporate as far as a radio type and batteries and whatever type of certifications you may be going for, try to engage a test lab as soon as possible and make sure that you are getting apples to apples comparisons from multiple labs in order to be able to pick the right one. So with that, I think we will need to wrap up here on production real quick, and then I know we're getting a lot of questions here in the Q&A, and I think there's a possibility that we can try to follow up with everybody after the session is over.
Absolutely, so, no worries.
We'll try to
address
Okay,
those.
perfect.
Well, deploying
Excellent.
is where many companies fall down, right? They get to the edge, the engineers have done an awesome job, the testers have done an awesome job, they have a great business model. But what they forgot is that in order to get the device out into the field, they need people who can do that. And that usually requires training, right? That usually requires cooperation with the locations that you will be deploying the system. For example, if you are going to be putting up boxes on a cell tower, you need to have a relationship with those cell tower owners and work with them. So production planning should happen at the planning stage, and you need to fully understand how you're going to deploy. If you have to go from making one trip with a truck to go put something out in the field, and that ends up turning into 2 because of some unforeseen consequence, you could probably blown the first year or 2 of your business model profits just because of that. So you really want to make sure you understand how you're going to deploy. Software, you almost have to use firmware updates over the air. If you don't think you need that capability, then you probably do. I don't think I've run into an IoT system yet where it wasn't important to be able to upgrade the software so you can add new features, capabilities, capacities to end devices over time. So you need to understand how you're going to do that and make sure it's rock solid. Ongoing certifications, this is Brandon's thing as well. If you get a cellular device certified or any other kind of device certified, it's not just a one and done. It has to be periodically refreshed, renewed, and you have to manage and maintain all your certifications. So make sure you understand that that's a big part of what you have to do, right? And then the data plan.
Dave, I just got to jump in here real quick. I know we have to actually go ahead and wrap this up, so I'm going to just jump us ahead real quick to some final things to think about. And then if anybody needs to get a hold of us, if you would like to get some more information about the information that we covered here, we'd love to talk to you. We'd love to get your emails. Any of those questions that didn't get answered, again, we're going to try to follow up with and get you those answers. There's some really good ones in there, so I'm sad we can't quite get to them. But with that, I want to say thank you very much, and I appreciate you joining us, and have a great conference, and we'll see you then.
Hey, thanks, guys.
Thank you.
Brandon, David,
Bye-bye.
Can't say enough. Really a great presentation. We do have a lot of questions that came in, and rest assured that those will be passed along to Brandon and David, and they will be able to answer you directly when the session is over. and we look forward to doing that. Our next session is provided to us from Telus IoT Platforms, titled "The Rising Role of Edge Computing in the Industrial IoT." And joining us for that presentation is Bill Dykes. Bill is product manager with Telus IoT Platforms. Bill's got over 15 years of business, market development, and product management experience in a broad cross-section of technology categories, but has specific experience with RFID, big data analytics, pervasive computing, and SaaS-based software strategies. At Telus, he works on the development of products and services that connect and integrate machines with enterprise IT systems. He also has past experience as part of IBM's pervasive computing division, developing and promoting its products and services for the wireless services marketplace. Bill, good morning.
Good morning. I'm going to have to shorten that. That's a mouthful of a good introduction. Thank you very much.
Thanks for being here.
So,
take us away,
I am the product. What's that?
Just take us away.
I'm the IoT Platform Product Manager, which includes both our cloud-based software as a service, which we operate internationally and also in a number of mobile network operators around the world. Also, as part of that IoT platform is specialized edge software that we put either on routers or specialized PLCs and systems acting as basically an event stream processing engine for dealing with data, reducing the flow of data, doing store and forward in case connections are lost, and it works with both cellular and non-cellular systems. So if you don't know anything about Telus, we sell two primary categories. Actually three, the software that I spoke of, and then also our connectivity services, where we have coverage around the world with partners to enable cellular connections to machine-to-machine devices, pervasive devices around the world. And then also probably our largest business is our cellular devices, everything from 2G, 3G, Cat-M, narrowband IoT, all the categories of LTE all the way up into new next-gen 5G modules. Let me start, and that's all encompassed on this first slide, the first mile of IoT. And one of the legacy aspects of that kind of has come into play in the first mile of IoT. When I say legacy, it's some legacy ideas. If we remember the days when the large IT and service providers looked at connecting to houses and other places, they used the connection, the actual from the curb to the street, as the idea of, that's the last mile. And that's probably an apt description of that connection when you're in a broadcast mode, i.e. broadcasting video on demand or broadcasting to the home services. But when you start getting into the IoT, we realize that the edge is actually the first mile. It's not the last mile. You have to start with the device because that's where the data is generated from. And so that is the first place that we get our data from. And so if you can't connect to those devices and then bridge that gap from the edge all the way to whether it be cloud-based systems or from Azure, Microsoft, IBM, and others, or private data centers, then you're never going to see the benefit of IoT because the edge is where the data is generated. And by the way, as the previous speaker said, that can be, the edge is kind of in the eye of the beholder, and I'll address that in particular from an industrial IoT perspective. But so crossing that first mile means you've got to go from the sensors and actuators, and they may be dumb data collection devices or data generating devices, but it may have some edge intelligence. And then there's the object of transporting it, which in Telus case we do through our connectivity management services. And then managing the data, delivering the data, curating the data, and delivering it to these enterprise systems, whether they be traditional enterprise middleware systems or the new next-gen cloud-based systems that are from the traditional IT companies like IBM, like Amazon, like Azure, companies that fully understand how to process the data, manage the data, store the data, and that's their lens. So how we would differentiate ourselves and actually differentiate when we start looking at that first mile is, which direction are you looking? Are you looking from the device upward? Or are you looking from the cloud and the application outward? So what's needed, and from a Telus perspective, this is from what's really needed from the industrial world. How are you going to manage in real time? And so, the keynote was a good lead into these details of what's got to happen at the edge. What's going to be your ability to manage real-time data ingestion? How about, what sort of rules do you have at the edge? We jumped right to AI and machine learning, but many of the edge processing activities that we talked about can be handled through basic event stream processing, a rules-based. That's not to say that AI and ML will not grow, but we're all still seeking the key applications that will leverage a trained AI or machine learning engine at the edge. You have to be able to access today's IT domain and tomorrow's. And some of those are manifested in cognitive cloud solutions, where the power is to easily get started instead of putting up private versions of what you need. You've got to provide secure remote access. We call that the technique that may be tunneling into a machine, but it's all part of a connected machine. How are both vendors and operators of the applications going to access the machines to maintain them? And in this day and age, what we've seen in the last, since the beginning of this year, that need for not having to send somebody out to fix a machine if it can be managed or operated remotely is key. It's got to be easy to deploy, and it's got to be future-proof. And one of the aspects that we'll see later on in one of my slides is how do you deal with the wide range of devices? Telus has a ton of experience and has key products that will enable your products or your machinery or your business to be wireless. But a lot of our customers in the industrial sector are still wired. They're still inside of factories like automobile factories, automobile part manufacturing companies like Honda and Ford, where they're collecting data from the factory floor. And so they need to know that whatever edge they have, that they can connect to it and that they can continue to grow their applications, because especially in the factory and industrial sectors, data, these applications and these business processes or these factory processes, some of them haven't been changed in years, and they really don't want that messed up, but they still want to understand what's happening with that process. So where is the edge? From an industrial perspective, almost everything that is from level 0 to level 4 can be an edge. The cloud is by itself, although there's definitely private clouds that are developing, or private instances that enable customers to maintain their own version of their cloud system or device management system in the cloud. We use a number of things. One of the what's sort of put labeled here as device-wise is our event stream processing software that operates at the edge. And part of what you have to do is deal with the different layers. And these are traditional factory layers, whether you're dealing with sensors at the very lowest level, how do you connect those to the control systems that are nearby? And then also, how do you deal with connecting those control systems all the way up to cloud and data analytics, or maybe you're just connecting it to your local ERP, MRP, and CRM system. So the ability to go between the multi-layered edge is critical to dealing with and enhancing your ability. And in the end, and I'll have a slide here in a second that talks about all the considerations of dealing with devices and machinery and connections to the edge in terms of managing the device, not just the device management. I break it down into three fundamental categories of how you have to deal with services at the edge. You have to deal with the device management. How are you going to do FODA? How are you going to do software updates? How are you going to update applications that may run at the edge? Or in the case of AI and ML engines, the algorithms that are tuned up based upon all the data that's sent to a data lake somewhere, and how do you tune up that algorithm that may be running at the edge? How do you deal with, being able to present data on your supervisory and HMI system? So and then there's the connectivity management, which may deal with, and maybe dealing mostly with the wireless connection. It was brought up earlier that, dealing with SIMs and managing the SIMs, managing the data plans. How do you make sure that your device at the edge is not runaway? The $1 a month data plan all of a sudden racks up a charge of $100. How do you monitor that? How are you alarmed for those situations when your edge might be going out of control? And so that's another critical aspect. And then lastly, the data delivery, which includes the normalization to the cloud systems, delivering the data. I mean, it's one thing to have the protocols, the ability to get a dial tone and send data across that line, but if the data is not in a form that's receptive, it's a little bit analogous to the old business intelligence systems where the phrase ETL, extract, transform, load, is fundamental to operating with the edge. And so some of the aspects, in particular, this is a slide that we use to talk about the value, but it's applicable of our OneEdge software, which is a software that runs on our cellular modules and enables out-of-the-box connection to cloud systems. But when you think about the edge, you need to take all of these things into consideration. How are you going to manage it? Will there be, when your device ships from your factory, will there be zero-touch onboarding to a platform? Meaning, does it automatically come out of the box and hook up? Or do you have to send a special service and support person to the edge to provision, set it up, and make the connection? Ideally, when the embedded system or connected machine comes and you install it, it automatically connects up to your systems, especially if they're remote. What sort of edge logic are you going to have with your system? We've talked a lot about AI and machine learning, but there are edge apps, and where are they going to run? Are they going to run can they run within your wireless module? Do they need to run on a host processor, or do you even need a third-party compute system, such as a industrial PC, or do you need to be able to have it run in your factory data center? That may be the edge. And so the ability to do those are separate, and those are OT systems. And I want to make the distinction here that I'm really talking about OT systems, operational technology systems, and what has to happen there, and not disrupt factory processes, but still get the data about how the equipment is running and how is the process running, as opposed to just the actual process control mechanism. How do you optimize the behavior and resource usage? And we talked about battery-powered devices, devices that have AA or AAA batteries that are supposed to maintain battery life for a year or two or longer if required. So that requires them to self-manage their power usage. Embedded security, making sure from out of the box that the device is secure, and not just the device, but also the platforms that those edge devices communicate with. How to make sure that the end-to-end system is secured and prevents improper usage and access to devices. The connectivity, service, and management. That may be wireless, but and that's the primary bucket item here in this connectivity, service, and management. Is how do you simplify that? How do you manage that? How do you ensure? And it is treated separately from your traditional device management and data management, because they're different operating profiles. And then lastly, getting that data to some enterprise system, whether it be a private data center, some other cloud system, or whatnot. So when we talk about an edge architecture, we see, it's very common to think of the edge as some wireless device that, in this particular case where I'm talking about the one edge with maybe a small piece of machinery in it, and they may have to connect over public cellular networks, but as we move forward, we're starting to see private LTE networks take up a place or within strategic thinking of what the next-gen communication system to be, whether it be a mining site or inside a factory. And how do you connect to machines that might be viewed as a factory-type machinery, but, stationary, whether it be, for example, a fracking truck that's sitting on an oil well is a pretty high-powered factory in its own way. And so you have to be able to get access to all the machines on that. And then lastly, I went from right to left, the connected factory, all of those things that are inside a factory, whether it be a paint line or a machining center or a torque wrench. The final build, and making sure that, whether your customer wants to send that data directly to cloud systems, still those other cloud systems, I think, have become specialized in their ability to manage data, but they're still not as skilled at managing devices. The industry protocols are there, but the numbers and the variety of devices are still confusing to them, and that's where other methods and other systems for managing the wide range of devices. So what I'm talking about is the goal of having a common architecture, and that does not mean having one system, but it means having an architecture that enables you to mix and match. For example, inside the factory, the ability to go between the OT and the IT systems that operate inside the factory and the hundreds of devices, and then quickly connect those plant flow devices to the enterprise. That's where we talk about the OT to the IT and move that data into all these different locations or present it to them in terms of other applications. Can your edge data be presented and analyzed separately or presented to you and shared with others? I think this will be a good timing. And I think the other aspect of the common architecture that this slide points out is when you're dealing with the edge, there's a huge number of device types, and this operational technology. These edge devices, whether they be programmable logic controllers from any one of these vendors or sensors or other aspects, and this is a specialty area of Telus industrial IoT, and these pieces of equipment are things that we've had experience with, and then the ability to take that data and manage it and deliver to these enterprise systems. I think I'm going to pause there. I think we're ready for some questions, or we can hand off to the next
Thanks so much, Bill. Really great stuff. Love the mention and emphasis, perhaps, of OT systems. That might be something I want to ask about. But I've got a couple of questions in front of me. First of all, can edge solutions operate independently of cloud components, and should they?
Absolutely. They can operate within the edge. It all depends on where you want the data to go, and they should and they could. A cloud is not always necessary. It all depends on what you're trying to do with your application. For example, we have customers that take the data directly from factory machines on the floor, and we connect to those machines and we present that data locally. It doesn't go into the cloud for change, but it goes to a local visualization system, HMI, and which is a human-machine interface, and so that's another integration point. The edge operating independently of the Internet of Things, it becomes a data-centric viewpoint. What are you trying to do with your data? What makes the best sense to where you move it to, how you move it, and then how do you present it or process it for options? And I think that's one of the areas that IoT is still maturing in, is how is it optimizing the use of these new data sources to improve business processes.
Right. No, great stuff. How about common architecture? Does that mean if a common architecture is being delivered, does that mean it's tied to proprietary protocols?
No, I think that from a common architecture perspective, and maybe we could use some better terminology here, but I think the idea is that when you're building a system, that you have the architecture that enables you to connect multiple things to it, where you don't, I think there's lots of cases where individuals and different groups are building their own system from scratch. And I think that's a straightforward, not simple, but what happens when you now have wired and wireless devices in the same IoT system, because you're trying to combine data from both trucks that are running, and you're really you don't want multiple systems to be delivering and managing the data for a single business process. Whether it be, we have a customer that builds factory construction equipment, not factory, but has construction equipment, and they use the data from those machines for predictive maintenance. They use it for a dealer network to geo-positioning. They know where they can present to their dealers so that the dealer knows where every one of those vehicles is. So the common architecture is the ability to connect the disparate groups. And in our case, we use common protocols, MQTT, lightweight M2M, all of the web services standards that are available today. There isn't a need to use a proprietary protocol. But that doesn't mean that you've got to have the ability to connect to machines that were proprietary from years ago. And there's the legacy environments that we're all trying to connect to, and there's a heck of a lot more of those than having to wait to replace all of them.
Right. Oh, hey, I've got another question or two, but we are right up against the time, so I'll just say thank you so much, Bill. Really appreciate you being here, and I learned some things, that's for sure.
Okay, thank you.
Our next presentation will begin in approximately 2 minutes. That's on hierarchical edge computing, a practical edge architecture for industrial IoT by Brandon Kennedy, who is the co-founder and chief product officer at Lucent, in approximately 2 minutes. So we are at 10 minutes past the hour, and we will be diving right into our next presentation. Just a quick reminder to everyone, please, we encourage you to submit questions, and during the presentations, that is. If we do not get to your questions during the live presentations, never fear. Those questions will be associated with your registrations, and our presenters will be able to address those after the live session. And with that, I'll bring on Brandon Kennedy, who is co-founder and CPO at Locent. Brandon's going to talk to us today about hierarchical edge computing, a practical edge architecture for the industrial IoT. Brandon, good morning.
Yeah, thank you. Good morning.
Take us away.
All righty. So thanks, everyone, for joining us today. And I'm going to be talking about a architecture for edge computing. And I've called it hierarchical because really this is a concept born out of the fact that there is no one edge. There's no single spot in your tech stack where you can take edge computing and plug it in and solve problems. And if you've been here all morning and saw the previous two talks, that was kind of reinforced. There are a lot of places for edge computing to be inserted into an IoT solution. And what I found across a lot of applications that we've helped bring to market is when you line all those up, they kind of start looking the same. You kind of get this pattern that emerges. So really, no matter where you insert logic at the edge, they can kind of be grouped and bucketed into the same shape. And I kind of call that the hierarchy. So a little bit about me. So you know who's talking to this morning. That's my picture on the left. The dice there is because I really like board games and card games. And when we used to be able to do conferences in person, I would always bring a couple of pre-built Magic decks, hoping to find somebody to chat IoT and play Magic. Unfortunately, that's not something we can do these days. I lead product for an application enablement platform called Locent. And what that is it provides edge and cloud building blocks on which our customers develop and bring to market their own unique IoT solutions. The right side, that's a subset of our customers. I've had the awesome opportunity to work directly with a lot of these companies in industrial, transportation, construction, oil and gas, helping them architect both their edge solution as well as the cloud solution. So my talk here, it's going to start conceptual, then it's really going to dive in to a tangible use case, really consolidating a lot of these ideas and commonalities across these customers into kind of one example that I'll step through and show how data traverses through this hierarchy from the device, eventually getting all the way up to the cloud. I'm going to be using these terms a lot in the next 20 minutes, so I thought it was probably important to provide some baseline definitions. There are a lot of definitions for edge compute, but for this conversation specifically, I'm describing it as compute or logic or intelligence, processing, whatever you want to say, at or near the physical device or at or near the source of the raw information. So really taking that intelligence, removing it from the cloud where we're kind of living today. There's no point in sending all that information up to the cloud to do a round of processing to send something back down. We can take this intelligence and bring it much closer to the source of data for really good reasons and optimizations. And then hierarchy. I think everyone knows the definition of hierarchy. However, I put it on here. Really, that's any system, a person, or in this case, things, one ranked above another. So if we get right into my definition of the hierarchy, and this one has 3 layers, but in reality, you could have more, you could have dozens, you could have fewer. But no matter how many layers you have, I found they kind of group into these 3 buckets. At the bottom, I call the embedded edge. Underneath my dashed line, I did put the also known as, or other terms you might have heard. Our ecosystem hasn't really consolidated on some standard terminology yet. So although they all kind of group around the same concept, they are called different things. So the embedded edge, I call that the device itself. That is the sensor. That is the controller. It lives inside the physical equipment or machine. That's as close to the raw source of information as possible. we go up the stack a little bit, up the hierarchy, we get to what I call a gateway edge. I really like the term gateway because it kind of has two definitions that do a really good job of describing it. One is if you just tell somebody, hey, I need to go buy a gateway, they're probably picturing the right equipment that usually represents that. It's like a Linux or Windows industrial gateway you buy from Advantech or Dell or something like that. So the industry has kind of coined, I'm going to go buy a gateway as kind of a computer. But also gateway has another definition to be like a bridge or a proxy. And I think that works really well in this scenario as well. It is a gateway between the embedded edge and layers higher up in the hierarchy or the cloud. It's providing that proxy, that bridge, or that gateway of information to allow that data to flow upwards. And then finally, a little bit newer that we're talking about now is kind of the network edge or the access edge. This is really coming out of a lot of the cellular operators when they're talking about 5G or CBRS. And I'm going to talk a little bit about that specifically later. But also we kind of see this as an extension of a gateway edge as well. A lot of people are putting a layer immediately before the internet to do either maybe some security controls or a little bit of buffering or store and forward, things like that. So we are starting to see a layer that exists right before the internet. We kind of call that the network edge. And one of the primary reasons this hierarchy exists is essentially an exchange. I'm going to exchange data fidelity for actionable insights. As data propagates up this hierarchy, the volume of information or the fidelity of that data is decreasing. But what's happening is your insights are increasing. So instead of just sending raw data directly from your embedded equipment all the way up to the cloud, that can be quite expensive, especially if you're talking about cellular. Why don't we put some layers in here that can crunch that data, do some form of processing, reduce the fidelity, reduce that volume, but in turn, we're going to get some insights. So I like this slide a lot. It does a really good job of helping clarify why do I need another layer or should I put another layer in this hierarchy. And to answer that, you can kind of think about, well, do I have more data than I need here? Can I process this data and turn it into something actionable, something I can actually use before I send it to the cloud or before I send it this stack? So it kind of can guide some decision-making processes when it comes to designing an actual hierarchy for your environment. And then what I want to do is I want to ground all this. I've been talking about conceptual, but who is this talk for, and why would you be pursuing edge computing? And if you come from process and controls and automation, you're probably pretty familiar with these levels of compute, your PLC and maybe some gateway and so on and so forth, the SCADA system and things like that. In a lot of ways, that does follow the same hierarchy. But my talk here is really thinking about a different layer of compute that kind of comes with more newer or modern IoT solutions. It really falls into kind of this remote industrial equipment monitoring. We're seeing a big trend right now for both manufacturing environment and what I consider OEMs, the actual the equipment itself. Can we add some tracking to actual equipment so that when I sell it to my customers, they can get some kind of service with the thing that they bought? So this is kind of what I'm using, the lens I'm looking through for the architecture that I'm going to cover in a moment when I get into a kind of a tangible example. And there's a lot of advantages to pursuing something like this. Obviously, it's proactive response to equipment conditions. A local control system will certainly respond to conditions, probably shut itself down, but you really need that kind of historical data or tapping into that in a different way in order to do a little more proactive monitoring. The middle one, optimizing field support, that's a really interesting problem that we see right now, especially in our current environment. We can't just be sending field technicians to customer sites. And unfortunately, that worked so well for so long, we never really considered that there might be a better approach. And now we're in a world where I just can't send a technician monthly, quarterly, or weekly to go check on something. I really have to focus that asset. I have to optimize deploying a technician to the field so that if I do send an actual person, it is for a real known maintenance reason. And then that last one, customer satisfaction. So this is for OEMs. Think about a generator provider, an air compressor, something that sells equipment. We're seeing a big trend right now of how do I tap into the existing data that equipment has in order to build and offer maybe a recurring service or something that the customers can tap into. I've got a great example for that. I literally just bought a tractor, and it's fairly new, and I didn't know any better. I've never had a tractor before. Industrial piece of equipment, fairly expensive, fairly modern. My first Google search was, where's the app that just tells me, when I'm supposed to change the oil and things like that. So it still surprises me as a consumer that these large industrial equipment that usually require a decent amount of maintenance don't have that service built in. So that's where we're seeing that trend to kind of push this capability forward. So now I'm going to get into an actual example, and it follows, an implementation that might go in place for somebody that's realizing or bringing to market a solution revolving kind of remote monitoring of existing industrial equipment. So let's start with the embedded edge. That is the equipment itself. So if you're talking about a manufacturing environment, that's probably a PLC. If you're talking about an OEM that's distributing fielded equipment, it probably has an engine controller. Both already existing rich sources of information. Oftentimes, there's no need for additional sensors. All we got to do is tap into it. That edge layer already has everything we need. And then there's retrofits. So if the equipment itself doesn't already have a sensor, we have to retrofit some sensors on there in order to collect some new information. All of these have quite a bit of intelligence built into it. When we see customers bring a solution to market, they're usually monitoring a couple of hundred telemetry metrics. I'm just going to focus on one. I'm just going to focus on vibration, just to kind of keep things simple. So the round of processing, the exchange for data fidelity to insights that the embedded edge is doing in terms of vibration is converting raw accelerometer data to actual vibration data. In order to generate vibration data, you have to sample the accelerometer hundreds of times or thousands of times per second. That's an enormous amount of data. You'll pass an RMS algorithm over that, and that will give you some frequency and intensity, and that's the insight that we actually need. So already at the embedded edge, it's already doing a fairly simple, in this example, piece of processing that has done a huge exchange for raw data for insights. So that raw vibration data or raw acceleration data probably never needs to leave the embedded edge. There's no reason to have that up the stack. What we do want to propagate forward is that vibration data. So now we get to that gateway edge layer. A lot of times, the embedded edge doesn't really know how to send data itself somewhere else. There are some more modern PLCs that do have MQTT clients that can directly push data outwards. Especially in a retrofit sensor situation, the sensor is entirely designed to be read by something else. So this gateway layer for an industrial equipment monitoring solution is really designed to tap in to the data that already exists on those controllers and those sensors. And it's going to be talking over, one of a half a dozen or so industrial protocols, OPC UA, Modbus, CAN bus. If it's a retrofit, new sensors, they might have some wireless options like BLE. That's where that industrial gateway goes in. And that's really going to be sampling. Again, that's going to be reducing the fidelity of data. I don't need the vibration data as fast as the embedded edge is using it. The embedded edge is likely continuously monitoring that in order to make decisions locally. The CNC machine and a bit gets cracked, it might start vibrating or shaking. It's going to shut itself down. But I want to be sampling that vibration data, and I also want to process it. I want to downsample it into something a little bit more actionable. Raw data points of vibration aren't useful. If a technician comes and bumps your machine, you're going to get a huge spike in vibration, but the machine's fine. So this is where maybe something like an average, that's a very simple one, but also machine learning inference, inference specifically, not training. Training requires a lot more resources, but inference can be done very quickly. And I mentioned a lot of the times the embedded edge is generating hundreds of telemetry metrics, so 100 or more dimensional data. That's pretty good type of data for machine learning. If you've got a lot of equipment, a lot of data, a lot of history that you can use, you might be able to train a pretty interesting machine learning model that could run right here on the gateway edge. But really the important part is it's sampling data from all of those machines at the embedded edge, doing some light amount of processing, exchanging some of that raw data for some higher level insights. And then now we get to the network edge. And in a lot of cases, this is transparent. So in some cases, the network edge is outside of your control. If you just purchase cellular connectivity or using your building's Wi-Fi or Ethernet, there still is a network edge. There's a lot of infrastructure and hardware required to give you an internet connection, but you're not using it for compute. It's basically a transparent proxy to the internet. In industrial environments, we do see another layer here. It's essentially an extension of the gateway edge, another gateway edge layer that's called the network edge, and it's really designed to consolidate all of that data from all of those gateways. Because you could have dozens, if it's a large environment, dozens or hundreds of gateways on the network. You know, the IT may not want each and every one of those to have internet access, so they can just forward all of their data. It's already been crunched. The volume's been already reduced significantly. They can forward all that data to another gateway, basically the exact same hardware, and that can do essentially store and forward buffering. That's the primary use case, so that if your internet connection does go out, it's surprisingly common for someone just to forget to pay the internet bill. So you want to be able to store that information. That way, if the internet does go down and comes back, your cloud side doesn't lose anything. But I really like this layer for notifications and alerting, especially in manufacturing environments. If your work order system, your ERP, is hosted on premises, which a lot are, your work orders, if you want to do automated work orders, in this case on vibration, if the vibration has been above some critical threshold for some certain amount of time, go ahead and automatically create a work order so a technician can check it out. That work order's got to go over your local network into your local ERP system, so you don't want to send that to the cloud and come back. So I like the network edge here for that purpose. And then I also mentioned multi-access edge compute, MEC. That is some new capability. So I want to spend just my last few minutes here talking about some upcoming opportunities we're going to see that I think will combine that transparent internet connection with compute capability. Because right now, there's really no way, if you want that network edge, you kind of still got to bring your gateway and put it right before the network. It's very difficult or sometimes impossible right now to get that connection to the internet, that network edge, and also deploy custom compute. There are certainly programmable routers from Cisco where they have application space, which that does technically provide that capability, but usually that's the domain of your IT department, and they're using that programmability for network-level logic, not application-specific logic. So you're not going to be able to go to your IT company or your IT group and say, hey, can I put an application on our Cisco routers to help out my IoT solution? They're going to say no. But we're seeing some really interesting trends with 5G and CBRS that they're really thinking about how do we deploy large area connectivity with compute directly in mind. And CBRS specifically, Citizen Broadband Radio Service, opens up some interesting capability there. Unlike 4G, where they took the whole spectrum and basically auctioned off big blocks, and really the only way to get spectrum is through a carrier, CBRS took a small piece of the overall 5G spectrum and said, you know what, anyone can use this. There's caveats, there's priorities. You know, if a Navy battleship comes in and needs some of that spectrum, they're going to get it, you're not going to get it. But what they found was the vast majority of the time, there is open spectrum for anyone to be able to use. So now what we're seeing is a big ecosystem of capabilities start to be formed, especially from operators like Verizon, infrastructure providers like Ericsson. They're really thinking about this. So thinking about how do I offer a kind of private cellular coverage, give people their own private network, can span a huge amount of area, but also directly expose forward custom compute capability so they can do that network edge. And the play for industrial is really in providing that widespread coverage in areas that don't already have it. And I see a lot of opportunity in like logistics, warehousing, where they could have millions of square footage and they want to move forward with an IoT solution, but simply the cost of rolling out a network is a blocker with traditional coverage technologies, Wi-Fi, Ethernet. Could be far too complicated, far too expensive. But you talk about cellular, you could put a few access stations, you can bathe, square miles of coverage. So all of those gateways that you might have deployed may not have to be on a Wi-Fi network. They can have a cellular modem talking to a private cell G or a private 5G network. So everything's still secure, and you can treat that as a network edge. So I would keep my eye on this capability. It's still early, but the major telco players are exploring this. So keep an eye on this as an option if this seems to work for you. So I'm at my 20 minutes. The last thing I'll spend just 10 seconds on. Yep, go ahead.
Oh, thanks so much. I just wanted to say thank you. Please continue.
Yeah, right on. 2 seconds on this. So how do you deploy this logic? That's where platforms like ours come in. There are a couple edge-specific platforms out there. We offer capability each layer, including even those telcos that want to sell or offer compute as a service through some kind of CBRS offering. So we'd love to talk to you, partner on how you might be able to use our platform to expose that capability to your clients. So with that, I'll end on my time. Again, I'm Brandon Canaday. This was Hierarchical Edge Computing. If you want to get in contact with us, learn more about our capability, find us at losant.com or shoot us an email at hello@losant.com. All right, thank you.
Hey, Brandon, thanks so much. And how remiss was I? Apologies once again. For those who are wondering about Brandon's profile, he is the co-founder and CPO of Losant. There he's responsible for driving the product vision, the marketing plan, and product support. And he spent a good chunk of his time understanding the customer-driven requirements of the product. I think you could draw that from the presentation he just gave. Brandon worked for more than 10 years in enterprise software, including experience in the government sector. He began his career at Griffin Analytical, went on to Interactive Intelligence, and in 2012, Brandon co-founded Modulus, where he was CTO in charge of all technology, architecture, and product engineering. Brandon, thanks so much for your presentation this morning. Really appreciate you being here, and I learned a lot, not just about the hierarchy of the edge, but fidelity versus insights, field support, security, great stuff there. I really appreciate it. Thanks so much, Brandon.
Excellent, thank you. And I see there's some questions, and like we said, we will get all of those, and I'll make sure to follow up directly with every question asked during my talk. Thank you.
That's great. Sounds great. Thanks so much. And once again, to remind the audience, we do encourage the questions. In some cases, we cannot get to them during the session, but rest assured they will get to the speakers, and they will be able to answer them offline. Our next session begins in approximately 2 minutes, where we'll have a presentation on industrial IoT at the edge, remote access to critical infrastructure, coming to us from Digi International. And so with that, we are 35 minutes past the hour, or shortly will be, and I'd like to begin our final session of the morning. That is Industrial IoT at the Edge, Remote Access to Critical Infrastructure, brought to you by Digi International. First up from Digi will be Randall Kerr. He's Director of Product Management. Randall has 3 decades of professional experience in the fields of education, IT management, infrastructure design and implementation, and product design and management. As Director of Product Management for Digi, he works with the product and engineering teams to design industry-leading cellular products and technical solutions that resolve customer business issues in enterprise, industrial, and transportation markets. Randall has for many years served the North and South American markets as Director of Sales Engineering, where he's known for his consultative approach. Randall, good morning.
Good morning. Thanks for the introduction.
If I could just quick get to Brandon, and then I'll pass off to you, Randall, if that's okay.
Sure.
Brandon Moser is also going to join us. He's Manager of Professional Services with Digi. Brandon's got 19 plus years of experience with IT management, web development, and engineering. He joined Digi in 2015 as a lead application engineer. As Manager of Professional Services, Brandon manages a development team focused on providing services to customers deploying Digi solutions. These include Modbus to SCADA systems development, hosted web application development, third-party API integration, and other mission-critical services. Good morning, Brandon.
Good morning. Thank you.
Handing off to you, Randall. Take us away.
All right. Thanks a lot. Well, we've got a good bit to cover today. We wanted to talk about industrial IoT at the edge, and kind of not only remotely accessing your critical infrastructure out at the edge of the deployment, but also engaging the data from it, and kind of what are some of the options, what are some of the things that we've done as Digi. So we've already kind of gone through the introduction, so I'm just going to jump ahead. We've got a good bit to cover today. The key points that I personally wanted to run through are, kind of leveraging cellular as a connectivity option at the industrial edge. I want to talk about some of the types of hardware features that can tend to be useful when you're engaging existing equipment, existing hardware out there. I'll talk a little bit about the Digi Remote Manager platform and kind of what it brings to the picture and why it tends to be important to a lot of our customers. And then I'm going to hand things off to my colleague, Brandon Moser, and he'll talk a bit about some specific application examples. His team has done just about everything you can imagine over the years. They're very, very talented. He's got some great examples to share today. So when we talk about connectivity at the edge for industrial environments, there tend to be a lot of options that are out there, right? The wired connectivity option, though, tends to be probably the least reliable, or at least the least available of those options, because often when we're talking about an industrial installation, there simply may not be a lot of wired infrastructure out there. And we've heard examples earlier about scenarios involving batteries or, potentially solar or that type of thing. And so that's where it starts to become challenging for using a standard copper or fiber backbone to provide connectivity. Satellite has been around for a really long time, but its economies of scale never really have kicked in. It tends to still be extremely expensive, and it also is not a terribly fast technology to this day. Private radio networks are yet another option. We do see those in certain industries like oil and gas and sometimes utilities, but they're incredibly expensive because there tends to be a lot of special licensing that needs to accompany them. Frequently, towers must be erected in order to run a private radio network, and somehow or another, at some point in that setup, you're still going to require some sort of a backhaul connection in order to get your data out to the data center at your company. So it's it still tends to be fraught with some issues. So that brings us to cellular, which is available just about everywhere at this point. It's relatively inexpensive. You've got a lot of public and private connectivity options for cellular, very reliable technology, and the great thing, it's fast. So when we talk about cellular for IoT applications, of course, the focus today tends to be industrial IoT. So you see some examples of the types of industrial cellular hardware that Digi manufactures. Digi actually builds cellular equipment for the enterprise space, the industrial space, and even for transportation, transit-related applications. We build our hardware for industrial use up to mil spec. It's designed for extreme temperature tolerance. We've got a variety of power inputs that you can provide to the unit. So if you've already got some sort of power supply out at the edge, then you're likely to be able to leverage that without modification when you want to drop the Digi into the solution. We try to build our units to where we minimize the amount of power that they consume, and we offer an extremely broad array of speeds in our units. So one of the things that we're very proud of is that in a recent model called the iX20, we've actually introduced a replaceable module architecture called the Digi Core, which allows you to tailor the speed that you're going to deliver to the needs of the application. So a great deal of flexibility. We go to great lengths to not only establish a connection, but to maintain that connection. We use a technology called SureLink that allows our firmware to literally monitor whether the unit is successfully passing traffic or not, and then it's able to take evasive action if necessary. And then the other thing is we provide a minimum of 2 SIM slots on our models so that you can have redundant carriers if you desire. So if one carrier simply goes down and is no longer transmitting, then the unit can automatically fail over to the other. We do have units that also have dual cellular radios, and that means 4 SIMs, so extreme redundancy in those instances. When we talk about connectivity, though, at the edge, you've got to bear in mind that there are a lot of types of hardware that you may need to attach to. And so that means that you've got to have some flexibility with regard to the interfaces that you offer. So what we're able to provide is connectivity via Ethernet. It could be 10/100, it could be gigabit speed. We also have a very long history, about a 35-year history at this point in serial technologies, and so we support RS-232, 422, 485, and of course that includes support for Modbus and SCADA type applications. We offer USB interfaces on a number of our devices so that you can have additional expandability if you need to integrate some additional type of edge component. And as I mentioned, we've got a really broad array of cellular speeds all the way from Cat-M or Cat-1 up to Category 18. And we're in the process of working out our first couple of 5G devices as well if a customer needs extreme speed. So this is a point that I think bears mentioning for sure. We have a designed-in security framework that we call Digi Trust Fence. And you can see over on the right, it integrates a large number of elements. We only allow, by default, secure ports of ingress. We provide the ability for a chip-level encrypted file system. A lot of elements that are designed in from the very conception of our devices, because where IoT is concerned, if you really look back through the last few years' history of major data breaches and hacks, a lot of times they tended to be related to IoT type devices. Now, that doesn't necessarily mean industrial IoT, but in some cases it does. And the reason is that because IoT applications often tend to be such thin, lightweight type applications and devices, security has been minimized or possibly even omitted in some of those instances just to keep the footprint as lean and light as it can be. Digi does not handle it that way. We absolutely think that that security is the cornerstone of whatever you're going to build, and we design it directly into our devices. All of our routing devices do support multiple VPN technologies as well. So if you want even additional security and encryption on top of what's already built into the device, then you always have the ability to build tunneled connections as well. There are a lot of use cases for cellular at the edge. You know, we talk a lot about connectivity, providing that connectivity for the offload of IoT data, and that's the one that we're going to focus on the most today. Another application is it's fairly common for there to be some sort of an HMI or human-machine interface out at the edge, and the customer would like to be able to interact with a facsimile of that interface without having to get in a vehicle or get on a plane and go out to that site. So leveraging port forwarding and pass-through technologies, we're able to deliver that type of experience as well. And then there's always secure out-of-band management. It's not uncommon for there to be a somewhat standardized stack of hardware out at the edge. And in a lot of instances, customers will use DigiCellular via a serial connection to obtain a command line interface to other devices at the edge and then manage those units. But like I said, today we're going to focus mostly on the one to the left with the connectivity for IoT data offload. So when we get into this topic, there are a lot of ways that you can look at this. So one is that when you introduce cellular out at the edge and you have a full router device that has all of the intelligence that routing can provide, then having an edge compute environment enables you to do a lot more with a single device, right? So you've got to look at this. When you're designing an IoT solution out at the edge, every additional piece of equipment that you plug in becomes another potential point of failure. So it tends to be to the customer's advantage to minimize those additional pieces of equipment as much as possible. And then the other thing to give some consideration to is how are you going to manage and monitor and secure all of the units that you're putting out in the field? Because typically if a customer is using a technology like cellular, it's because there was no better option for connectivity out at that location, which means the location is far away from where the customer actually is going to be. And so they've got to have some sort of tentacle that's going to give them reliable access into those units so that they can push out firmware updates. They can update programming code that might be running on the units. They can push out additional configuration changes as they might be necessary. Now, the other thing that Digi strives to do is to provide as much flexibility as possible for edge development. Now, if you look at the ring of examples over to the right, you'll see that the top one says DIA. Somewhere on the order of 15 plus years ago, Digi introduced a framework that we called DIA, which was very cutting edge at the time. It was basically a pre-built selection of drivers that would make it point and click simple. We extended that capability and made it much more flexible by leveraging a full-blown Python environment, which we maintain and we keep current to this very day. We do offer Bash scripting as well, which is, I guess, the Linux comparable equivalent to the Windows PowerShell, or if you want to really simplify it, to batch files in Linux, except batch files on steroids. We also support the use of native C Linux applications on devices running Digi-accelerated Linux, and we're on the verge of introducing containers in the form of Docker, which is going to make things even more flexible because customers will be able to use essentially any development environment that they might like to create a solution and deploy it to the edge. So back to the topic of IoT data offload at the edge. There's a really big point here, and this was sort of mentioned earlier in a couple of the other discussions. You're going to have a tendency to generate an extremely large amount of data if you're waking up and running sensors on a regular basis. But if you're running on a full-blown industrial router like some of the models that Digi manufactures, then you don't even necessarily have to have those sensors go to sleep. You could just take nonstop reads if you would like. And so you do have to kind of step back a little bit and say, well, look, how much data do we really need, right? And how frequently do we need to be taking these reads? But then you start getting into more, and there you come into questions like, which data are we really interested in? Because as you're taking constant reads, you're going to find that a lot of those reads are identical to each other or virtually identical to each other. And so if it all becomes heartbeat data like that, then do you really need it reporting in constantly in real time? Or would it make more sense to perhaps hold on to that data and only report it up every once in a while? Or perhaps hold on to it, aggregate it, or average it, and then report it up on a certain interval? And then otherwise, look at the outliers. And if we start seeing outlier data that might indicate that, hey, a crack is forming, we're losing pressure in an oil well casing, or it looks like power is beginning to flicker on a certain part of the grid, something like that, then perhaps that becomes a point where you want to report it up immediately. So when you take these types of approaches, you can realize data and bandwidth savings and enjoy a little bit more efficiency. And that's where edge computing becomes really appropriate to the application. So I've already kind of covered the examples of edge computing that Digi tends to provide. So the other thing to think about is, how are you going to integrate your data? What are you going to do? So a lot of customers just want to send data directly from a Digi router or a Digi gateway up to Microsoft Azure, AWS, Google Cloud, one of the major ERP applications. In other instances, it might be that they're already using Remote Manager to centrally manage all of their devices, and Remote Manager also happens to have the capability of providing a great back end to accommodate data that's coming in from Digi devices. Then if a customer wants to later leverage that data in another platform, they could leverage the API that's part of the Remote Manager system as well. So a lot of options as far as kind of how and where you send the data. And again, that flexibility tends to be provided by the edge compute environment. So last couple of things that I'll mention. We were talking about Digi Remote Manager. On its surface, it is a device management platform. It's designed to give you an easy way to manage, monitor, and update all of your Digi hardware that you might put out into the field. But it also serves as a complete solution enablement platform. And if you take a look at kind of the bottom green rectangle, you'll see that there are a lot of points about the system where you can engage the data in the form of data streams. You can leverage the API to both push and pull data. Great deal of flexibility. So let me hand off to Brandon Moser at this point. Brandon?
Hey, I'll try to get through this real quick. I know we only have a couple minutes left. So just a few examples on some of the things we have talked about or we offer, looking at being able to put Python applications or other applications at the edge in cellular routers or things like that. We've actually been able to develop full applications in those spaces. Some of those things include like putting a Modbus server that talks to Modbus clients behind the scenes and being able to scan them, as Randall had noted, at a regular base, and then only uploading data as we need it to the end device, but still providing the local HMI to the local HMI at a regular interface, at the regular scan rates that kind of SCADA systems and HMI want it. And so we've provided that to a lot of customers that have those tank monitoring solutions or oil monitoring or other sensors in the back end, and being able to provide that data as they need, and then also configuring alarming and things like that, things that we would consider to be AI or being able to concern whether it's a good bit of data or not a good bit of data, and whether we get that involved. We've also done things where we can help with router configuration and monitoring, being able to get that installed and up into the cloud, or actually being able to do automatic configuration on the router itself based upon what we do and what we see in the environment. And then I also wanted to cover, we do offer, obviously things like our DigiXP routers, and offer solutions that can do local radio networks and then provide that same Modbus interface at our gateway. And so we've developed a couple different solutions that allow, being able to do wireless to wireless communication, cellular to then a radio frequency network at our gateway, and provide that type of solution in that edge device, going down even deeper into your back-end edge, where you're connected to then sensors. And lastly, I just wanted to talk about, we had one other project that we worked on, which is out-of-band serial monitor, and gave us the opportunity to monitor the serial communications inside of the gateway, the router, that actually could communicate to multiple points versus just a single TCP to serial type communication. So I know there's probably some questions on those, and we didn't have a whole lot of time on this, but if you have any questions, happy to go to to answer those at a later time.
Yeah, thanks so much, Randall, Brandon, and Digi International. Thanks so much. Learned a lot. We do have a question or two, and rest assured that we will forward those questions to Randall and Brandon, and they will be able to answer them offline. Your registration will be associated, so they'll be able to get back to you. Thanks to all of our presenters today, and to our audience, of course. We do have another session starting in just about 3 minutes, which is Cloud Platforms and IIoT. Please join us for that. You can access it directly through the registration for this session, so should be just a click away. Thanks again, everyone, and appreciate your time.